Alright, welcome to Chemlight. Today we are going to be looking at an important topic in chemistry which is called stoichiometry. Now, this is basically what the whole concept. As you can see, these are all the formulas we are going to be needing for stoichiometry. But that's not just all. There are a lot of things we are going to be doing. Now, if you take a look at this exercise, this is going to be the first one we're going to be working on. But we can't just jump into solving of stuff. We have to make sure we know the basic properly. I want a scenario whereby if you are just seeing stoichiometry for the first time, you'll be able to understand. Even you that has been seeing it over time, but you still find it hard to understand. With the help of this video, you will make sure to understand this video. Now, let me give you a quick run on how we are going to study stoichiometry together. Now, I'm going to start first with the parameter. As you can see, everything here are all symbols. You might not be familiar with the meaning of these symbols. So we're going to start with the meaning and the definition. And I will explain to you how and when we are to use all this. Aside from all these parameters, we're also going to be looking at what? Conversions. There are lots of conversion. We have mass conversion, temperature conversion, pressure conversion, and a lot more. So now, aside from the conversion, then we'll also be needing balancing of the equation. So now, this video we are going to divide it into sections to make sure you don't miss any part of this video. Make sure you watch this video to the end. So now, what you do now for me, you get your writing materials, your pen, your book, and also your calculator, because we are going to be doing a lot of calculations. Okay, now take this time, few seconds, to click the subscribe button so that you don't miss any video on this topic and any other topic in chemistry. So now, alright, let's move on. Now, we are in what? The mole concept. The whole idea of mole concept is all around one single thing, and you should understand that it's all around this symbol we see here, n. And now n is denoted for what? Number of moles. So every single formula you see here will give us one thing, number of mole. If we use this formula, it give us number. We use this one, everything is just number all around this one thing, number of mole. So make sure. Now, what I will do for you is that I will explain for you what number of mole means. As you see, these are the symbols for the parameters. So as we explain, I will write their names for you. Now, for this one, n, which is the basic thing we need to know, is what? Number of mole. So I'm going to write now. Number of what? Mole. Now, this guy called number of mole can also be called what? Amount of what? Amount of substance. Amount of substance. Now, some question will say, what is the number of mole of so element or compound? That is that. Another question can come this way. What is the amount of substance, or what is the amount of sodium in, you get? So if you don't see number of mole, you might see amount of. So take note of this. Now, this guy is what? Measured in what? Mole. Take note. Alright? The full form is what? MOLE. But now, if you want to write it in short, you just MOL. Alright? So now, what is number of mole? If we are to look for number of mole, we should what? Know the meaning of mole. So now, I'm going to give you a very brief definition of what? Mole. Now, first of all, a basic definition. Mole is what? A unit used to describe a certain amount of particles in a given sample of matter. That's just a basic definition. Now, for example, on a real life scenario, what I can explain as mole now, for example, if we want to buy eggs. Now, how do we buy eggs? We buy it in what? Dozens. And what is dozen? Obviously, when you hear I want to buy egg, 1 dozen, we already know it's what? 12 eggs. We can also buy eggs in crates. So it's exactly the same thing. When we're talking about mole, there's a particular amount of particles we are talking about. And this particle is what? 6.02 times 10 raised to power 23. Okay, it's called Avogadro's constant. It's actually, we're going to talk about it here, so I don't want to write it here in this front part. But get that as an information. Now, let me give you a very standard definition of what we call mole. Now, a mole is an amount of substance in as many elementary particles. Now, this elementary particle, be it what? An atom, molecule, or ion, in exactly what, as they are in exactly 12 grams of what, carbon 12. Now don't be confused. Now let's see exactly what, 12 grams of what, carbon 12. We have a lot of isotopes of carbon. We have carbon 12, which is the major isotope of carbon, the most abundant. We have carbon 13, we have carbon 14. Carbon 14 is what, the radioactive isotope of carbon, used in doing what, carbon dating. Just take it down, that's the jam question. Okay, so now if we are using carbon 12 as the major carbon, when we use 12 grams of carbon 12, what the molar mass of carbon is what, 12. Now this is what we got our first formula for what, finding number of mole. Now look at number of mole is equal to mass over molar mass. They say 12 grams, so we use 12 grams, 12 over molar mass of carbon is what, 12. So now remember, molar mass is measured in what, mole per what, is measured in gram per mole, sorry. So now gram per mole, so if mass is measured in grams, now if you count 12 cancel 12 is 1, right? What gram will cancel gram is out already, so what is remaining is mole. So you get, that's what we call 1 mole. So that definition is how we came about, that's how we came about this definition. I believe we understand what mole is now. Alright, okay, so now let's move next to the next parameter we are seeing here. M. What's the meaning of M? It's simply what, called mass. Alright, this is mass. What is mass? Mass is the weight of a substance in gram. Very, very simple. It's just simple as that. Okay, now the next parameter we have here. Now take note to the first parameter is for small letter n. We use this small letter n to denote number of moles or amount of substance. Small letter n is used to denote what, mass. Then this capital letter N is not for mass also. We use it to signify, it's a symbol for what, molar mass. Okay, alright, so now guys, what is molar mass? Molar mass is the amount of 1 mole of an element. Sorry, take note, molar mass is the mass of what, 1 mole of an element or compound. It's as simple as that. Now molar mass, remember mass is in grams, right? Now molar mass is in what? Now sorry, let me just write it down for you. Hope you guys are taking note. If you've not brought out your pen, please bring out your pen. You have to take note of all these definitions I'm going to be giving. It's very important for the understanding of this topic called stoichiometry. So molar mass is what? Gram per mole. Now if you don't see this gram per mole, we can also see what? We can also see the unit as what? Grams per mole. You can also see it like this. So don't get confused when you see this guy. Alright? Okay, so now the next thing we are going to be looking at is C. What do you think this C is representing here? This guy. This guy is called what? Concentration. Now in the equation you might see what is the concentration, but sometimes you might not see concentration. What will you see? You will see molar concentration. Is the same thing. If you don't see molar concentration, you might see what we can also call molar concentration. We can also call it what? Molarity. Okay, so when you see the three of them, they mean the same thing. Okay, so now guys, what is molarity? Molarity is the amount of 1 mole of a solute in a decimeter cube of what? Solution. I come again. Molarity or molar concentration is the amount of 1 mole of a solute in what? A decimeter cube of solution. Take note of that. Alright, so now let me write the name of what this C. We use C to denote what? Molar concentration. If it's not called molar concentration, we call it what? Concentration. If we don't call it concentration, we call it what? Molarity. Okay. Now, how we measure molarity in what? Mole per dn cube. Take note. We measure molarity in what? Mole per dm cube. Alright, now the next parameter we are going to be looking at here is volume. What is volume? I know we basically know what volume is, but now a standard definition I'm going to be giving you guys on volume, pressure, temperature. Now, pay attention. Now, volume is what? Volume is the three-dimensional space occupied by a substance. It's just simple. Volume is what? The three-dimensional space occupied by a substance. Now, volume can be what? The substance which is what occupying this volume can be what? A solid, liquid, or gaseous. Take note. So now, alright. So this V is what? Called what? Volume. Alright. So the next thing we are going to be looking at here is what? Molar volume. Now, molar volume, this what? Capital letter V subscript what? M. You know what? Raised to power is superscript, right? So subscript is down. So like capital letter and small letter. Alright, take note of that. This is the symbol of what? Molar volume. So now, okay, now molar volume is what? Molar volume is the volume of one mole of an element or compound at what? STP. Now what's the meaning of STP? STP means what? Standard temperature and pressure. What did I say? Molar volume is the volume occupied by one mole of an element or compound at standard temperature and pressure. Now, what is standard temperature and pressure? It's simple. There is a value, a constant for a standard temperature and a standard pressure. Now, the value for what? A standard temperature is what? Now, I'm going to write it up here. 273 Kelvin is the standard temperature. Now we also have what? A standard pressure. Now the standard pressure is what? 760 millimeter mercury. Take note of this. Okay. Now, if there is a standard temperature and there is a standard pressure, in these circumstances, this gas will occupy this mole of the one mole of this gas will occupy a certain value of what? Volume, and this volume is called molar volume. It's a constant. It has a constant value. So now we have the constant value of a volume called molar volume to be what? 22.4 dm cube. Now this is the value of molar volume. Anytime you hear STP, know we are going to be needing these three values you are seeing right here. Now, your question might be in cm cube, might be in dm cube. But if it's in dm cube, this is the value you'll be using, 22.4 dm cube. But if it's in cm cube, make sure to convert it to cm cube. Now we can convert the value to cm cube to be what? 22,400 what? Cm cube. Alright? Sorry. Okay. Now, let me write it. It's called what? Molar volume. Okay guys, now the next thing we are going to look here is what? Pressure. Pressure is what? The force exerted per unit area of a substance, usually what? A gas, when it collides in the walls of its container. This is a very standard definition for pressure. Okay, so this we use P to denote what? Pressure. Hope you are following. Be taking note of these definitions. Alright, we have here temperature. T is for what? Temperature. Alright, temperature is what? The degree of hotness or coldness of a substance. Alright, usually related to the average kinetic energy of that substance. Alright, that's a good definition for temperature. Now, note. Sorry, I'm not giving you the units of these guys yet. Volume can be measured in what? Can be measured in meters, milliliters. Sorry, can be measured in what? Meter cube, meter square. Can be measured in what? Milliliter. Can be measured in what? dm cube. Can be measured in what? Cm cube. Alright, take note of these units of volume. Alright, for molar volume, especially in stoichiometry. Now, for molar volume, we just have two. It can exist as what? Merely as what? dm cube, decimeter cube. Alright, or what? cm cube. Hope you get. Now, for pressure, pressure has a lot of measurements. It can be measured in what? Atmosphere, atm, or what? Millimeter mercury. This one you saw here can be measured in what? Pascal. Can be measured in Newton per meter square. Or finally can be measured in torque. Okay, all these things we are going to see them in what? Conversion. When we are doing conversion, we are going to do a conversion aspect of this class. So we are going to be looking into each and every conversion scale. Okay, now for temperature, we have a lot of temperature scale. The most common, which is what? Celsius, degree Celsius scale. We have what? Kelvin scale. Now in chemistry, take note of this thing. In chemistry, we mainly use what? Kelvin scale. So anytime you see in equation, a stoichiometric equation, you see the temperature is in what? What in degree Celsius. Make sure to convert to Kelvin, or else you will get the wrong answer. Now, if you see your equation in grams, leave it like that. If your mass is in grams, leave it like that. But anytime in chemistry, especially in stoichiometry, you see that your equation was given to you in kilogram, convert to grams please to get your correct answer. Now, in physics, that's what we use what? Kilogram. In chemistry, we mainly use grams. Okay, take note of these two things I just told you. Alright, so now the next thing we are going to be looking at here is what? Sorry, I've not told you all the temperature scales. As I said, we have degree Celsius, we have Kelvin scale, we have what? This thing, Fahrenheit scale, and we also have Rankine scale. Alright, so now let's look at what? Arrow. What does arrow denote? It denotes what we call the what? The molar gas constant, or is also called the ideal gas constant. Now, the molar gas constant is a physical quantity. Take note, right? Is a physical quantity that what? Relates the energy scale and the what? Temperature scale in the ideal gas law. Take note of this definition. Alright, not everybody will give you a definition for what? Molar gas constant. Alright, this arrow is used to denote what? Molar gas constant. Now, molar gas constant, as you hear the name, is a constant. It has value. The way our molar volume has value, 22.4 dm. This molar gas constant also has a value. Alright, and there are two of them. So now I'm going to write the value for you. 0.08205. Take note of this value. Also take note of this guy. 8.314. Okay. Now, in a stoichiometric question, we might encounter this value. How do we know when to use this and when to use this guy? Now, when your volume is what? In what? dm cube. When your volume is in dm cube or in milliliter, and your pressure is in what? atm, my dear, atmosphere. If your pressure is in atmosphere, please use this value for molar gas constant. Now, hope as I'm explaining these parameters, you are also looking at the formulas. Alright, and you need to understand these guys before you will be able to apply these formulas. You don't just cram, you won't understand. Okay, now for this value, when do we use this value? Is anytime your volume is in what? Your volume is in cm cube. If your volume is in cm cube, your what? Pressure is now in what? Newton per meter square, or what? Pascal. When your pressure is in Pascal, you are to use this value. Please take note of this thing I'm telling you. Now, finally, okay, this guy, we have a number of particles. Now, don't confuse this n with this n. The first n was what? Number of moles. Now, our second n is what? Number of particles. They are not the same thing. We use capital letter n to denote what? Number of particles. Now, when we mean number of particles, we can also be talking about number of atoms. We can also be talking about number of what? Molecules. And we can also be talking about number of ions. Alright. So, number of particles, capital letter N. We are talking about number of atoms, number of molecules, number of ions. So, anytime in the equation you see number of particles, please, is this guy we are referring to. When you see number of atoms, we are talking about this N. When we see this number of ions, we are talking about the same thing. Now, look at it. This is where the formula we are going to need this guy. You remember? So, number of particles, or number of atoms, or number of ions, or number of whatever, over what? L. What is L? That's what we come back here. Alright? So, number of moles is equals to capital letter N over L. What is our L? It is used to what? Denote, capital letter L is used to denote Avogadro's constant. Alright. Avogadro's constant is it, we use L to denote this guy. So, do you remember in the latter part of this video, when we were defining number of moles, I made mention that 1 mole is what? Avogadro's constant. 1 mole is equivalent to Avogadro's constant. 1 mole is equal to 6.02 times 10 raised to power 23. Now, the value of Avogadro's constant is what? 6.02 times what? 10 raised to power 23. Now, this is not in millions, this is not in billions. This is a very large number, which is why, like, scientists were not able to count these atoms, these particles. They were too small to count. So the only way we could be able to give them, well, we were able to give them in one value, the way people sell eggs in crates. In fact, just chill. Hope you understand what I'm trying to say. They just needed a huge value to represent one. That is, they were representing this huge value with just one thing called a mole. A mole is equals to this. Do you understand like when they tell you what? They tell you that I want to buy a dozen of eggs. You automatically know that the person wants to buy 12 eggs, right? This is the same thing we're talking about. Anytime you hear Avogadro's constant, what are we talking about? We're talking about 1 mole. So now let me define Avogadro's constant for us. Avogadro's constant is the amount of particles in 1 mole of an element or compound. I come again. Avogadro's constant is the amount of particles. Be it what? When we get amount of particles, we mean what? Be it an atom, molecule, or an ion of an element or compound. Take note. Alright. Now we have 2 more parameters to talk about. We have Q and F. Now what is Q and F? I will have to wipe this place out so that we will talk about Q and F. No, we are not only going to be talking about Q and F, because aside from all these parameters, there are things we are also supposed to know. Things like what? Relative molecular mass, relative atomic mass, empirical formula, molecular formula, and percentage composition. If we don't know these things, we might come across them in stoichiometry. That's why I like arranging my stuff so that you don't get confused. Okay, now let's go. Thank you for watching. Now, I believe that learning doesn't have to be boring. It has to be fun, and mostly fun. Not mostly fun actually. Okay, so now check your sweet drop. It's always there. Thank you for watching.
I want to answer your question.
Sure, baby.
It's me and you. Who will get married first?
Are you joking?
I should be asking you because you're talking like you've seen your husband. So I don't know if there's any plan you have.
So what plans do you have for me?
See, what I want is for you to be my girlfriend until I find my real wife that will be the flesh of my flesh, the bone of my bone, the body of my body, till death do us part.